Another related rate problem. Oil spilled from a tanker anchored in the harbor spreads out in a circular slick. So I have a circle. When the rate of the slick is 100 feet, okay, so when this is 100, the area of the slick is increasing at 50 feet squared per second. Find the rate of increase of the radius of the slick at that moment. So I'm given that the area is changing at 50 feet squared per second. I am supposed to find how fast the radius is changing when the radius is 100. And r equals 100. Alright, the formula I'm going to be using is area of a circle, so a equals pi r squared. Take the derivative with respect to time, dA over dt equals 2 pi r dr over dt. Well, when I plug in the known values, one of my known values is dA over dt is 50. I have 2 pi. I'm plugging in 100 for r. And I have to solve for dr over dt. I end up getting 50 equals 200 pi dr over dt. Divide by 200 pi on both sides. So that gives me 1/4, or 1 over 4 pi is my dr over dt. And radius is described as, in this problem, feet, and then the time is in seconds, so it's feet per second. Next example, I'm actually going to skip, but I will tell you that the answer is 100 feet per second. I'm going to continue on to this next problem. A body travels on the circle x squared plus y squared equals 25. When the body is at 3, negative 4, the x component of velocity is 2 units per second. So we're talking about velocity. We know that's the derivative. So dx over dt is equal to 2. Find the y component of the velocity. So we're supposed to find dy over dt at that point. Well, I need to just go ahead and take the derivative of this circle. So the derivative would be 2x dx over dt plus 2y dy over dt equals 0. I need to solve for dy over dt. So what things do I have? Well, I know that I have a 2. Right here's my x, and there's my y, so my x is 3. My dx over dt is 2, plus 2 times my y value is negative 4, and I have dy over dt equals 0. 2 times 3 times 2, well, let's see here. That's 12 plus negative 8 dy over dt. I'm going to solve for dy over dt, move the 12 over, and then divide by 8, or negative 8, which gives me negative 12 over negative 8. That definitely can be reduced. 4 goes in each one of those, so I have the answer being 3/2 units per second.